Yuji Yokoo, everyone, talking Megaruby on Sega Mega Drive.
Thank you for the introduction, and thanks everyone for your patience. We had a bit of an equipment issue. That's what you get for trying to connect 1980s equipment into modern AV system. But yeah, somehow we've got through it. So here I've got my Sega Mega Drive connected, and the output you see is the output from the special cartridge I've got, which lets you boot any ROM file on your SD card. So I've got a few ROM images, and this file in particular is a presentation I'd like to do now. So let me get started. So here we are. Okay, and well, this is RubyConf AU 2023, and probably this is the first time you see this on a Mega Drive screen. And I'd like to thank the organizers and staff and everyone involved to talk to so many people about Sega Mega Drive. That's amazing, and I hope many people here are paid by your employer to be here, and you can go back to your employer and report that you've learned how to develop software on the Mega Drive. So also, again, CipherStash. I started working for CipherStash at the end of January, and I've been there for just a couple of weeks, and this presentation has nothing to do with what they do. But they were still happy to pay for my accommodation and airfare and all that to be my speaker sponsor, so I'd like to thank them for that. And here we are. This is my presentation application's title screen. I wrote this in Ruby and used some C, and I called it Mega Present, and because it's a presentation application that runs on Mega Drive, it's Mega Present. And after some modifications I did last year, I started calling it Mega Present Dash, and I did some more updates, so now I'm calling it Mega Present Dash Plus. So yeah, eventually it'll be Super Mega Present and everything. So, all right. So here's the table of contents. I'd like to tell you at the beginning maybe a little bit about me, and then tell you what Mega Drive is, because I'm guessing some of you people here are too young to know what Mega Drive is. And also mruby and mruby/C, which you may not be aware of, and why mruby makes sense on Mega Drive. And also there's something called SGDK I'd like to tell you about, which is the software development kit I've used. And also I'll give you a little bit more on information on Mega Drive, and I'll show you some example, just tiny bits of Ruby and C examples to show you, give you a little feel of what it's like to develop software on this. And I'd like to conclude this with a little demo game. So this is me. This is the pixel art version of me, and I work at CipherStash, and as I said, they don't do any Mega Drive software development, but I'd like to say that hasn't happened yet. And I'm based in Adelaide, Australia, and there are some social accounts if you'd like to contact me. And okay, let's start with what is Mega Drive. A Sega Mega Drive, also known as Sega Genesis in some parts of the world, was a video game console released in 1988. And it features Motorola 68000 as its main CPU, running at 7.6 megahertz. And here, I have my spare one. I've got one connected, and here's my spare one. And on its body, it proudly said 16-bit. It was a big deal back then to be a 16-bit game machine. And also, Mega Drive features 64 kilobytes of main RAM plus 64 kilobytes of video RAM. So it's not gigabytes or megabytes, it's kilobytes. So even if you have a fairly expensive and powerful notebook, they might come with 64 gigabytes of RAM these days, but this is we're talking about 64 kilobytes here. And also over 30 million units were sold. It was very popular back in the 80s and 90s, and it was probably more popular outside Japan than in Japan, even though the company that produced it, Sega, was Japanese. And now you might be wondering, what is mruby? So mruby is yet another implementation of Ruby. There's JRuby, and there's cruby, and truffle Ruby. Mruby is another one. And if you're not thinking about if you're not aware of the implementation you're using, you're probably using cruby. And mruby is intended for the embedded environment. So it integrates well with C. And you might be thinking, you can call C code from Ruby code via native extension. Yes, that's true, but that's calling C code from Ruby. The other way around, calling Ruby code from your C code is actually a lot more, isn't easy. But with mruby, you can do that quite easily. And feature set is quite, actually fairly limited. It's still implements almost full ISO standard, but things like require, eval, and RubyGem, things that are dynamically loaded at runtime are typically not available in mruby. Everything's done, and when you compile the program into a binary that runs on the platform. And that's mruby. So what about mruby/C or mruby-C? Well, C stands for compact, and it's a project from Shimane IT Open Innovation Center and Kyushu Institute of Technology that provides a compact VM for mruby. So it's a VM-only project. So mruby distribution comes with tools like interactive environment and the bytecode compiler, but mruby-C only provides the VM, and that's more compact. It's typically not faster, but it focuses to be really memory efficient, and also there is no support for mrubyGem, which I didn't mention while I was explaining mruby. But mruby lets you add features at compile time through a system called mrubyGem, but there's no such thing in mruby/C. So that means every feature you need has to be in your source tree. And you might be thinking, why would you want to develop software for Mega Drive? It's 2023. Yes, but there are good reasons. So there are lots of good open source development kits, and I use one in particular called SGDK. I'll tell you about it later. And because so many units were sold around the world, you can still find second-hand ones quite easily. And also, besides the second-hand units, you can get new Mega Drive compatible game units, which means if a Mega Drive breaks, you could potentially replace it with a compatible implementation from other companies, and some of these are FPGA based and considered to be very high quality. And also, it makes a big difference to the development process, but there are many good emulators. I'll tell you more about it later. And also, you might not be aware of it, but there are so many active projects on Mega Drive still. So lots of indie studios are still making games. Often they make multiple platforms, like develop for multiple platforms, including Mega Drive. And also there are lots of homebrew developers like myself who write just not as a indie studio, but just an individual. So that's Mega Drive. And then you might be thinking, but why would you use mruby-C on Mega Drive? Well, it's Ruby. You get to write Ruby. So I think that's a good enough reason. And also what happens is typically you have to write some C to load your mruby code. And once that's started, your Ruby code runs. And whenever you need to interface with the platform API, you have to do some C. But really, the middle part is all Ruby, and you have to use some C, but the core logic can be written in Ruby. And I'd like to tell you a little bit about SGDK. SGDK is Sega Genesis Development Kit. It's one of the open source development kits for the Mega Drive, and it provides C API, so you don't have to write everything in assembly. And it comes with many nice features like memory management and graphics features like managing tiles and sprites. I'll tell you a little bit more about those later as well. And comes with a default font. So what you see on screen, those characters are all from SGDK's default font. And it does a lot of nice things, comes with nice things like resource compiler, which lets you put your assets together. And also I use something called gendev, which lets you run SGDK on Linux. And, oh, by the way, those, I'm not sure if you could see those wombats at the bottom of the screen, but they are sprites. Sprites are those movable graphic elements on screen. And SGDK's, when you use SGDK and mruby together, mruby focuses to be a library, and SGDK projects typically expect a main entry point to your program and build an executable and make a ROM image based on that executable. So what I did here was I checked out the entire mruby source code and added my main entry point and a few modifications and to build a Mega Drive executable and use that to build the ROM image. And in the process, I cut out a lot of features. And there's a little bit about Mega Drive graphics. Mega Drive has what's called video display processor. So everything you see on screen comes through the video display processor, and it runs at about 13 megahertz. And it operates in NTSC and PAL. And probably many people here would know what these things mean. NTSC and PAL were the TV signal standard back when everyone was using analog TV. So NTSC was more popular in USA and Japan and many other places, and PAL was primarily popular in Europe and also Australia. And Mega Drive is aware of 512 colors, 3 bits times RGB, 3 colors. But at any given moment, you can only use 61 colors on screen, but you can't just use any color you like anywhere. They're organized into tiles and palettes. So each tile is associated with a 15 or 16 color palette, but out of these 16, one is reserved for transparency. So that gives us 15 times. Because there are four palettes in Mega Drive, 15 times 4, that gives us 60, plus when there is only transparency specified, there's a default background color. So that gives us 61 colors. And everything is tile-based, so everything you see on Mega Drive is drawn as a collection of tiles, even with large images. And if you can see those characters right now, they're actually 8 pixels times 8 pixels, so they're all tiles as well. And yes, sprites, those wombats are sprites at the bottom of the screen. So here's an example. There's just to demonstrate how tiles work in Mega Drive. So there's a map of Australia with Melbourne, where we are, and Adelaide, the best city in Australia. And when you see images like this on Mega Drive, it is actually organized of those tiles. So everything, even large images, they're always made up of 8 pixels times 8 pixels tiles. And also, VDP has a nice scrolling feature, hardware level scrolling. So what you can do is to have background images set, and you can specify the offset, which lets you, which automatically scrolls the background to the specified position. But whatever that my explanation may not be sufficient, it may not be so good. But if I can show you the example, here's the sky background, and the also, well, often I call this background and foreground. So the ground is the foreground, sky is the background, and I can scroll these things like this. So this is in a loop, changing the offset at each iteration. So if you can see, the sky and the ground are moving separately this is different directions and different speeds. So with development on Sega Mega Drive, there are lots of challenges, but the most prominent one was 64 kilobytes RAM. So running Ruby happens to be a language that does a lot of allocation and deallocation automatically, and I had a lot of memory issues when I was trying to build lots of string objects while I was trying to draw a complex screen. So I ended up doing lots of manual optimization, like pre-rendering all the images, like all the text into an image file, and using DMA to transfer without going through the RAM from the ROM to the video RAM. And also, there's a problem if you're using if you're developing for a video game console, there's nowhere to see your output. So if you do printf or put s and you want to put some debug messages, there's nowhere for it to go. But fortunately, emulators, especially I used one called Gens Kmod, which added nice window for all the console messages. So that helped a lot in debugging. And also, I have not used it myself, but it has some features like GDB, the debugger, remote debugging connection, and many other useful features. And here's the overview of how you would develop how you would develop a Mega Drive game using SGDK. So you write your C source, and you make your resource, which is assets, sound files and image files, and you cross-compile the C source for Motorola 68K, which cross-compilation is when you compile your source for another platform. And that produces object files, and you use SGDK's resource compiler to produce compiled resource file, and you put them together and add SGDK library and other things that comes with SGDK, like ROM headers, and you can produce a ROM file that can be run on Mega Drive. And here's what happens if you're using, or at least how I did mruby/C with SGDK. So I checked out the entire mruby/C source code, and I added some my C code, and I wrote some Ruby source and used mruby's bytecode compiler to produce bytecode, put them all together, and prepared the resource separately, cross-compiled the source files into object files, and here the process is the same again. So this that makes a binary that's written in, or that's produced from your Ruby source file. And this is an example of how you start mruby C programs from C. It's not really important to read this, but if you can note some, there are function calls to mrbc underscore functions. These are provided by mruby C, and this part surrounded in red, that's the part that initializes the VM, and the next part loads the bytecode onto VM, and then you run the VM and close it down. So this you can consider it a little bit like a boilerplate code, but you need a little bit of C like this to start your program. And I've been talking about resource for a while, so I'd like to show you a little bit of resource declaration here. So here, in a resource file, I say there's an image called rubyconfau.png and I'd like to call it RCA. And this makes RCA available in my program because this generates a header, and this goes into the ROM. So what's interesting, perhaps if you're only writing programs on modern computers is that usually your assets go to your assets are saved on the disk, and you have to read the disk to your RAM to be able to use those assets. But here, it's built as part of your ROM. So that means when you start your Mega Drive unit, it already goes into your memory, but it's adjacent to your in the same address space to your RAM. So there's no you can directly start reading it like your memory, but it's just not writable. And here's the just the red part that this is C code that calls the SGDK function for drawing the image. Here I'm using the previously declared RCA image. And here, this is a part that defines a function that's callable from mruby. You don't need to really read this, but there are like parameters, mrb underscore VM, that's the virtual machine, and also other mruby related things are handled here. And after that, you do this in, again, this is done in C to create a class and attach that function to the class. But once you do all this from your Ruby code, you can just call that function like this. This is very simple Ruby code. So, and when you do that, you get an image like this on screen. And here's another example. There's not much to it. It's pretty much the same thing. But here, this is calling the logging platform library's logging function. But this is where you can pass Ruby formatted string, and eventually this gets converted to C string and output to the log. And this is the very, very simplified version of my presentation application's main function. Here's a main loop, and what I'd like you to see is this is all plain Ruby. So this is what mruby code looks like when you, well, it's a little bit simplified, but everything is just Ruby once you handle all the platform calls. And also, I'd like to just quickly show you what my application does. So I write these slides in a text file, and this is a page example. Equal sign denotes a new page, and these title tags and text tags. So these tags define the content, and when you with the previous page slide page definitions like this, you get something like this on screen. And now, with all the Mega Drive features and development process and everything explained, I'd like to show you a little demo game. So here, if you can see, the sky is moving slowly, the ground is moving slightly faster, and the spikes are moving a little bit faster than the ground. And this ninja and spike, those are sprites. And these are, well, this game was developed for Ruby Kaigi last year, which was heavily ninja themed. So, but yeah, there's not much to this game. So here's a list of things I'm intending to do on this project. I'd like to write more games, maybe something a bit better than the one that I've just shown you. And also, right now, everything I wrote and original mruby C code are so intermixed together, and I can't separate them. So I'd like to separate them a little bit more. And also, when I looked at the code again to do some updates for this presentation, I found everything to be pretty hard to deal with. So I'd like to improve the developer experience there. And these are the URLs for, well, I've recently created a web page for this project, and these GitHub links are for the presentation source the presentation application here, and also the bottom one is a demo game that I'm about to show you. The one that I've just shown you, that's just part of this presentation app, and I've got another demo game. And also, I'd like to thank people who made amazing software so that I could work on this project. mruby, mrubyc, SGDK, and GenDev, because without these tools, I wouldn't have been able to do any of this. So with that, let me get into the demo game. So I'm resetting this, and now there's demo game and there's rigged game. I'd like to go to the rigged game, suspiciously titled one. So you might remember this game from a while ago. This was very popular like last year. And every time I did this for demonstration, I used mruby as the answer. So let's go straight to that. Oh, wrong. Oh, wrong. Yeah. And there we go. Oh, wait. I changed the answer. And oh, actually, I know the answer, but let me pretend that I don't know the answer and make a guess. Maybe it's tanks. Oh, T is in the right place, and A and K are used. So maybe it's this one. So thank you, everyone.
Yuji, thank you so much. That was a fantastic presentation. Yuji Yokoo again, everyone.
Thank you.